Hello, in this video we're going to talk through writing out molecular and net ionic equation for some double displacement style reactions. So these are aqueous reactions which follow a pattern of two compounds coming together and then the cations switch places forming two new compounds. And we will observe a reaction if one of the products is either a solid, a liquid, or a gas. If both products are aqueous, we will see no reaction. Looking up here at the top, steps to writing out a reaction. First, use our pattern to determine what our products are. So basically, who are our new pairings, who are our new compounds. Then use charges to determine subscripts. Then, after you have the subscripts figured out, that's when you start using coefficients to balance. This order is very important here. You have to figure out what the subscripts are going to be before you start balancing. And then you're going to ionize as needed to determine the net ionic equation. Who should ionize? There's only two examples of things that should ionize. We see them a lot, but the things that should ionize are aqueous ionic compounds, like salt dissolved in water, it's going to ionize, and then aqueous strong acids. So those things totally ionize. If it's not one of those things, it doesn't ionize. They'll stay stuck together. So we'll come back to those rules as we go through. So this first one, we've got aqueous lithium carbonate. So lithium carbonate, lithium's plus 1 ion, carbonate's minus 2. So I need Li2CO3. That's aqueous. Aqueous magnesium chloride. And think about here, notice I'm considering charges. I'll write this down at the top. Magnesium is a +2 charge. Chlorine has a -1 charge. I know that from looking at the periodic table. So that means this is MgCl2. That's where that is coming from. And it forms a precipitate. So double displacement tells me that my cations are going to swap places with each other. So my lithium is going to go with my chlorine, and my magnesium goes with my carbonate. So that was my step one. I figured out who are my new pairs. And then step two is I'm going to use charges to determine subscripts. So lithium has a +1 charge, chlorine's -1. Don't need any subscripts here. So I'm going to scribble this out. Over here, magnesium's got a +2 charge, carbonate's -2. So again, I don't need any subscripts here. Alright, so I figured out subscripts. Then I'm going to use coefficients to balance as needed. So like right here, I've got 2 lithiums on the left, but only 1 on the right. So I'm going to put a 2 right here. And then I think that's all I needed to balance it. Cool. And then my next step, ionize as appropriate to determine the net ionic equation. So I know these things on the left are both aqueous. I'm going to use my solubility rules to figure out that lithium chloride is aqueous, because it's an alkali metal compound. Magnesium carbonate is not on my list of things that are aqueous, so I'm going to assume that it is a solid. So now I'm going to ionize my aqueous ionic compounds. So that means over here I've got 2 lithium ions and 1 carbonate ion, and then I've got a magnesium ion and 2 chloride ions, and over on the right I've got 2 lithium ions, 2 chloride ions, and a magnesium carbonate. This right here that I wrote is what we call the complete ionic equation. And then I want to eliminate spectators, things that look exactly the same on the left and the right. So I'm going to eliminate my lithium and my chloride, and what's left over is carbonate and magnesium combining to make MgCO3. So that is a precipitation reaction. We formed a solid. Looking at this next one, so HCl is a strong acid, and it's reacting with sodium sulfide. In double displacement reaction, so the Na goes with the Cl, and the H goes with the S. Looking at charge, this is +1, -1, so no subscripts needed here. H is +1, S is -2, so I need to put a 2 right there. Okay, now let's look at states of matter. So sodium chloride, it's an alkali metal compound, so it's going to be AQ. And then H2S, this is something you want to spot from your table here of reactions to know. When you see H2S, this is one of the gases that forms. So H2S is actually a gas. And then you're going to ionize where appropriate. So I'm going to ionize all my aqueous ionic compounds and my strong acids. So H+, Cl-, I make 2 sodium ions and 1 sulfur. Oops, I just realized I didn't balance it. Whoops. Let's go back here. 2 and 2, I forgot a step. Go over here, I've got 2 sodium ions, I've got 2 chloride ions, and I've got H2S gas. And notice my sodium and my chlorides are spectators, so what's left over is 2H+, and S2- makes H2S gas.